It's like I don't care about nothing, man. Yeah. Oh,
So this video is going to be about z-scores. I think the easiest way for me to do the videos is to have one video be about z-scores using a calculator, the other one to be using the z-chart. So this one will be the ones where I use a calculator, and then the other video will be the one where I use the z tables. So the idea of a z-score or z-value is to find the exact amount of standard deviations from the mean. So the formula is x, which is the observed value, minus this symbol here, which means mean, over standard deviation. So the mean is always 0 because that is the very middle. If you're at the mean, you're not going to the right or left. You're right in the middle of the data. Now, any x value that is to the right, or z value, I should say, is going to be a positive z value. Anything that goes to the left will be a negative z value. So the problem on page 13 that deals with z-scores, it says, suppose the SAT scores among U.S. college students are normally distributed with a mean of 500 and a standard deviation of 100. What is the probability that a randomly selected individual from this population has a SAT score at or below 575? So based on that, first thing you have to do is find the z-score. So the x would be the 575, the mean 500, and the standard deviation would be 100. So that's what I did here. So now you have 75 over 100. So you have a z-score of 0.75. So the idea is that if the middle is 0, so remember that the middle is 0. If I'm at 0.75, I'm on the right side. So I am trying to find what percentage, because when you talk about probability, that means percentage. What percentage is to the left of this number? Because we're wanting to find it at or below. So I'm going to show you what to do with the calculator. So I know this is going to be a little ghetto rigged the way I show it, but to make it so we can actually put this into the calculator, we're going to click second, so this blue button here, bars, which is right underneath the down symbol. You're going to get a bunch of options. I want option 2, the normal CDF. Now, the lower value I can keep the way it is right now, where it has the -1 E99. Let's say there was something already in there before and it didn't show this. You can also put -99999 and put a bunch of 9s in there. The idea is just like what we were saying. We want at the number and below. So we want to just make sure that below is just a large negative number, just so that we can get the most accurate data. And now my upper value is going to be the z-score that I just found of 0.75, because that's the highest the value we want it to be. The mean stays at 0. The standard deviation stays at 1. Click paste. Click it again. And if you notice, it's the same number that that I had up here, 0.7734. So I suggest rounding to 4 decimal places, because if you're using a z table, that's how far it gives it to you as well. So using a calculator, those are the buttons you would use. So now just directly under it, it says how many students out of college that has 28,412 students are expected to score better than 575. So instead of wanting everything to the left side, we want everything to the right side. So we have a lower value, but we want our upper to go on forever. So one way that I can find what percentage it is since I already know that up here it was 77%, I could subtract 1 from 0.7734 and get my percentage. So that is one way of doing it. Another way is by using the calculator. So I can show you that. If I were using the calculator, since I want to find the upper value, I would do again second vars. I want number 2, which is the normal CDF. This time my lower value would be the 0.75 because that's as low as I want it to go. Now my upper I want to go on forever, so I'm just going to put a bunch of 9s in there. And go to paste. And it ends up being 0.2266, just like we have there. So in case you wanted to use the calculator for it, you could have done it that way as well. And since they want the exact amount of students, I take that percentage, multiply it by the amount of students, and since you can't have 0.1592 of a student, I just rounded to 6,438 students. So that would be the amount that's expected to score higher than 575. So the next one that I want to show you that I did in class before is number 2 on page 17. On this one, it says the intelligent test scale is composed of a number of subtests. On one subtest, the raw scores have a mean of 35 and a standard deviation of 6. Assuming these raw scores form a normal distribution, part A, which is what I'm focusing on, it says, what number represents the 65th percentile? What number separates the lower 65% of the distribution? So again, this is the one I'm showing how to do it with a calculator. You notice that I wrote inverse norm 0.65. The reason I did that is because that's what I'm going to put into the calculator. So since they want what separates the lower 65% of the distribution, I can use the percentile that they gave us. So this will give me this will end up giving me a z-score. So the way we do this, we do second vars. I want the inverse norm, which is number 3. The area is going to be whatever percent they gave us, so 0.65. And I use 0.65 because that's everything to the left side. Press enter, and I get 0.3853204, and so on and so forth. I ended up rounding to 0.39. So now that you know your z-score, since they want to know what number separates everything, I then have used the formula for a z-score, except now I know what it actually equals already. So we're going to be working backwards. So x minus 35 over 6, where 35 is the mean, 6 is the standard deviation. Then I multiplied 6 to both sides. So now you have x minus 35 equals 2.34. Add 35 to both sides. So the x value that represents the 65 percentile would be 37.34. So that's how you would do it with a calculator. The last thing I want to make sure to make a point about is number 3, part A. It says, what is the minimum score necessary to be in the top 15% of the SAT distribution? The one thing I want to make sure you know is that when you're dealing with the percentage that you're going to use, you want to be talking about anything to the left side. So since this one said the top 15%, I wouldn't use 0.15. I would use 0.85 because I need everything that's on the left side. So this is the number I would be putting into the calculator instead of that. So this will make it so I can find my z-score. So that's the end of this video that has to deal with z-scores. So main things to remember, this was the one with calculator. So if you have a calculator, you can do all the things I showed you. You want to make sure to remember how to get there. So if you are trying to have a lower and upper value, you're going to do the normal CDF. And if you're trying to find your z-score because you already were given a percentile, you would then make sure to do the inverse norm. So I hope this was beneficial. The next video that I'll have in here is going to be going over how to find those same exact ones, except now with using a z table instead.